All right, so I had some issues with my sound on the last one, so I'm back to using the traditional microphone instead of the cool wireless ones. But I mean, now you work with what you got, you know. Anyway, so last time we were talking about, what were we talking about? The last time we were talking about triangle proportionality, and if you have two parallel lines, if you have a parallel line that bisects part of a triangle, that it creates two similar triangles, and if they're similar, you can solve for x, you can find all sorts of different properties about it. Um, there are other things that you can do to change or alter or manipulate the triangles that also produce similar triangles and also produce similar measurements. For example, if we start here, we've got what are called altitudes. Now, if you have two similar triangles, as I presume ABC and EFG are, if you drop an altitude is basically you take a point from an angle and you drop it to the opposite side so that it forms a 90-degree angle when it lands. Then this triangle, ABD, is going to be similar to triangle EFH. At the same time, triangle FHG is going to be similar to BDC. Either way, this length BD is going to be proportional to FH. And it's also going to create, like I said, it's going to create two new triangles that each of them are going to be proportional to the other. So yeah, that's something else. That's, another trick you can do. Similarly, if you take a look at the angle bisectors, an angle bisector is a line that cuts an angle into two equal parts. So bi means two, sector means cut. So what you're doing is whatever this angle measurement is at Q, it's cutting it directly in half. And wherever it lands, obviously, it's going to create two triangles, one here and one here. Well, if triangle QPR was similar to triangle UTV, then triangles QPS and triangles UTW, likewise similar. Similar at the same time, triangles SQR are also going to be similar to WUV. And you got a lot of these questions of why does this matter? Why is this important? Well, you have a worksheet to get through, so we'll start there and work our way up to more practical applications after the fact. But if it works with angles, well, guess what? It also works with just sides. So whatever this angle is up here, it doesn't really matter. If you can draw a line here and it cuts the opposite side into two equal parts, which is what these two hashtags represent here, into two equal parts, then these triangles, again, LNM and HJI, they're going to be similar, and triangles LNK and HJG, those are also going to be similar. So, given that, let's see what kind of problems we can solve with this. So here it looks like we're starting with a median bisector. So what that means is that we can use the convergence. So what that means is we can use the different conversion factors. We can use the different scale factors in order to solve for x. So in this case, I see 19.2 and 16, and then I see 24 and 20. So 19.2 and 24 are going to be, they're basically going to be the same. Those are going to be the same relative sides. And so those are going to be what I base my scale factor on. So if I've got going large to small, I'm going to go from 24 to 19.2. That is going to give me the same as 15 to x. So now that I have the scale factor set up, now that I've got the algebraic expression set up, now I can solve for x. So that gives me 24x equals 15 times 19.2 gives me 288. Therefore, x equals 288 divided by 24 equals 12. Well, there we go. So a lot of these relationships, a lot of these theorems, a lot of these properties, all they're here to do is to help you figure out a better way, is to give you all sorts of resources and tools to figure out how to calculate x. How can we solve for x in all these different situations? So if you were concerned that geometry wasn't giving you enough math to do, well, I hope you are happy. All right, so we know For this next one, here we go. We know that GHI is proportional to MLK, so GHI, so GHI, so GI, and then L is 1, 2. It's just a habit of mine from one of the earlier lessons. So, all right, so GHI is the same as MLK. We need to solve for this. All right. Well, I can see between angles 2 and 3, which is the x side, x is going to be proportional to 14. But the only other information that I have is from the altitude that's from the altitude that's starting at angle H and then forming a 90-degree angle at point J. Well, like I mentioned earlier with the properties up here with the altitudes, these are going to be proportional. These are, because they're similar triangles, these are also going to be proportional. So if they're proportional, that means that I can set up the scale factor to help with I can set up a scale factor to solve for x again. So if x is to 14, so going from large to small, that means that 10 goes to 8. So 8. So that means that I've got 8x equals 140, just doing some basic cross multiplication. 140 divided by 8 equals 17.5. So x equals 17.5. Do a quick reality check. Yeah, that makes sense. I can believe that. It's not like I calculated x to be like 40 something or x to be like 2, and then I look at it, I'm like, I don't think that's 2. Yeah, in this case, 17.5, that looks pretty good. That looks pretty consistent. So I can move on to the next problem. All right, this one looks like it's going to be an angle bisector. So we'll take a look here. I've got angle ABC, so A, E, and then B, and then C is equal to angle E, G, and then F. All right. So again, the side between angle 1 and angle 3 is going to be X. And so that means that the side between angle 1 and 3 here is going to be 38. So from small to large, it gives me x is to 38. Now I just need to find a proportional side or a proportional thing that I can. Oh, well, I guess that works out pretty well. They're the only other two numbers that are available, so that's usually a pretty good hint that they're the numbers that you're going to use. 24 to 32. But in this case also, these are because they're angle bisectors and they're bisecting congruent angles on similar triangles. These lines are also going to be proportional to one another. So what that leaves me with is 32x equals 38 times 24, which is 912. So x equals 912 divided by 32, which gives me 28.5. Does that look about right? Yeah, I can get behind that. Yeah. So there we go. All right. So now this one is actually pretty interesting. This one is interesting because it's a scaling triangle, so none of the sides are exactly the same. But what you're doing is you're dropping an altitude from an angle all the way down to the triangle's base, but neither the base nor the altitude technically exist within the triangle. Can you do this? The answer is absolutely yes, you can. And even though if the two triangles are similar, which we're told they are, then that means that if you drop the same altitude from the same general location on similar triangles, then the altitude, however far it drops and however far away from the bottom part of the triangle it is, that is also going to be proportional as well. So what that allows us to do is it allows us to set up, I'm going to do small to large again. It allows us to say that x goes to 42 the same way that 12 goes to 15. So 15x equals 42 times 12, which is 504. So x equals 504 divided by 15. Going to give me 33.6. Yeah, I can do that. Yeah, I can believe that. Again, like I said, I'm not breaking out like my I'm not breaking out calipers. I'm not breaking out a ruler to measure the specific distances. If I solve for x equals 33.6 and it looks like that, then yeah, I feel pretty good about it. All right. Unfortunately, this does have a back to it, so we're gonna keep the ball. So we're gonna keep things rolling. And all right. So we'll go ahead and get started here. We got K, Y, C. Because something tells me I'm going to have to do some pretty clever arrangements. Okay. So we have to solve for we have to solve for x again. Let's see. Well, so the line between 2 and 3. Do I have any information on that? Yes. Okay. So 2x minus 9, and I'm going to go large to small this time. So 2x minus 9 is the large one. So there's the line between 2 and 3, angles 2 and 3. And the line between angles 2 and 3 on this one is 15. All right, this goes to 15. And so I'm going to do the bisector, so that gives me 20 and x minus 5. Okay, so it is the same as 20 to x minus 5. All right. Well, let's go ahead and we'll get this ball rolling. To start with 20 times 15. That's going to be the easy one, equals 300. So we'll do, let's see, get my calculator here, 2x minus 9 times x minus 5. Enter. Alrighty. So that looks like we've got 2x squared minus 19x plus 45. So we've got, now I'm going to, so I know what the solution is. The solution is I'm going to take 2, so I'm going to subtract 300 from both sides. 2x squared minus 19x, and then 300 minus 45. That's going to give me minus 255. That's going to equal 0. So what it basically means is I'm going to have to do the quadratic equation again. I do not like the quadratic equation. Well, I mean, I did when I was in when I was in high school, because I understood how it worked, and so that put me a little bit above where the rest of my classmates were. 255 equals 0. So basically, because I understood how to use the quadratic equation, that gave me a little bit of an edge over the. But you do more advanced math over time, and eventually the quadratic equation just sort of becomes. It's not so much that there's anything wrong with it, but it's not as cool as it used to be. Not that it was probably ever cool. But anyway, I end up, according to my calculator, where you have the x equals plus minus, so that gives me x equals 19 plus 49 over 4, which is equal to 17, or x equals 19 minus 49 over 4, which gives me negative 7.5. And well, I can't really have a negative length, so I'm guessing that x is going to equal 17. Because if I put in negative 7, so if I put in negative 7, that gives me negative negative 15 minus 9. So I mean, we're not dealing with negative lengths. So if I do 17, so 34 minus 9. So again, the reality check. If I let x equal 17, 2 times x is going to be 34 minus 9 is going to be 25. Can I believe that this length is 25? Yes, because this one is 20. And again, passing the reality smell test, I can get along with that. So, So yeah, hope your kung fu is strong, kids. Next one, we're going to take a look here. So we've got the next theorem that we're basically going to look at is the triangle angle bisector theorem. Um, so yeah, I mean it basically means that anytime you have the angle bisector and it's going to separate the opposite side into two segments, it basically means that the other two segments are going to be proportional to one another. All of it comes back to proportionality, and it comes to solving for x, and yeah, um, yeah, there we go. So that's about that. We can let's go ahead and start solving some problems. I don't really have anything more elaborate to say about that except it's a just another way of setting up proportions. So let's start with this one. All right. Well, I will admit I had to consult my notes a little bit on this because when I reread the triangle angle bisector theorem, and it really did not make any sense to me. So like I said, I had to read through my notes. I went through the geometry textbook that I keep on the back of the shelf here, and the best way that I found that it explains is basically with a drawing, and it's not really one of those well used or well known bisectors, but anyway, it's one of those tools that you just kind of keep in the back pocket. Whether you use it or not, I think that there are better tools and easier tools to work with. But anyway, say that you have a triangle ABC, and then this angle here, and then you have an angle bisector, brings it down to point D. Brings it down to point D here. Oh, there we go. Now we're centered. What the angle bisector theorem says is that side AB is to side AC. So the ratio of this side to this side is going to be the same as the ratio of side BD to side DC. So the ratio of this side to this side is going to be the same as the ratio from this side to this side. It's not really one that I remember very well from my own class or anything that I've run into. It's not very intuitive, and so that's why I kind of wrote it off to the side just to kind of keep an eye on it and keep it present in mind. I hate to say this, but there are some things in math that aren't going to make sense, and you just need to memorize them or memorize how to do them. One of my favorite examples, well, quote unquote favorite, is integration by parts. You'll get into that in calculus. I have taken nearly half a dozen calculus classes. I've taken differential equations. I've taken numerical analysis, and I've taken integral calculus specifically. I still do not understand the idea behind integration by parts. I know how to do it, and I can do it very well. But if you ask me to explain it beyond this is the procedure, I'm not going to be able to help you with that, which hopefully no one in the hiring committee hears that when I petition to teach calculus. Anyway, here we go. We've got the general rule written off to the side here. I'm going to keep my eye on it as we move forward with some of these examples. So we have to solve for x. Alrighty. Well, if I remember, so AB is proportional to AC, so 12 is to 18. The same way that 4.8 is proportional to x. All right, well, 12x equals, okay, 18 times 4.8 equals 86.4. So x equals 12, 7.2. Can I believe that that's 7.2? Yeah, I can. If that's 4.8, it's close, but I don't see any reason not to go along with it. All right, so we'll move on to the next one. All right, this one's a little bit shaped weird, but again, the principle's going to hold true. I'm just going to go left to right. So 54 is to x, that's AC, as 40 is to 36. So that means 40x equals 54 times 36, 1,944. Therefore, x equals 48.6. Does that pass the reality check? Well, if that's 54, all of these numbers are all weird. These drawings are all weird because there's no way if this is 40 that that's 54. And if that's 40, I mean, at least the 40 and 36 work all right, but 48 being 50, I don't like it. I don't like it. But I mean, that's what the theory says. This side and this side is proportional to this side the same way that this one is proportional to this one. And I mean, I'll try it again. 54 times 36 is 1,944, and then 40, and then 40. Yeah, I mean that's. Yeah, that's it. I mean, it's. Anyway, moving on. This one we have a little bit more work that we have to do. So 15 minus 39. Anyway, 39 minus 15. This one's going to be 24. And we need that information because we have to set up our proportions. So x is to 36 as 15 is to 24. Yep, I'm just making sure that I'm doing the same thing over with all the other problems. So, yep, so that gives me 24x equals 36 times 15, 540, divided by 24, x equals 22.5. Yeah, I can see that. Yep, if that's 24, that's 22.5, yeah. And again, the eyeball test is kind of, I'm not going to say that it's failing us, but it's, some of these drawings aren't really to scale, so you just got to do the best you can. Oh, booger. All right. So, okay, all right, we can do this. All right, so 30 is to 18 as, and that is to x minus 12 is to 12. Ha-ha! There we go. So again, 30 is to 18 as x minus 12. So this whole thing is x, but if I subtract 12, that gives me this value here is to 12. All right. So now I just got to solve some equations through. So 18x minus 12 times 18, 216 equals 30 times 12. Oops. 360. So 18x equals 360 plus 216, 576 divided by 18 equals 32. Yeah, I can get behind that. That whole thing is 32. Yeah. So, all right, we're doing pretty well here. We're getting on. We're catching on to things. We're keeping on, and just referring to this only part of the time. Let's take a look here. So we've got. Oh, all right. I mean, I don't mind. It's like I don't mind clever. I actually love clever, but what bothers me is just busy work. All right, so this gives me 3x minus 9 is to x plus 11 as, here we go, 45 minus 27 is 18. Alrighty, well that wasn't too bad. Okay, so 3x minus 9 is to x plus 11 as 27 is to 18. All right. Again, I don't mind clever. It's just busy, just mindless busy work with button pressing. And so that gives me 54x minus 18 times 9, 162. I redraw that 4 so I don't get confused. 54x minus 162 equals 27x plus, and then 27 times 11, 297, yes. Subtract 27 from both sides. That should give me 54 minus 27 should be 20, yeah. That gives me 27x, and then 297 plus 162, 459. So x equals 459 divided by 27, 17. There we go. Oh, close one. Absolutely close one. I can't believe I almost turned the page and walked away from the problem. My goodness. The reason that I'm surprised, so x equals 17. Yes, x absolutely equals 17. However, we were not asked to find x. We were asked to find length KL. I spent the first, I can't remember which worksheets it was, but I spent so much time talking about answering the question and losing points if you didn't answer the question that, anyway, I caught it before I turned the page and turned in my assignment. So if I need to find KL, KL is equal to 17 plus 11, which is 28. There we go. That is the real final answer. Whew. Almost got me. Almost got me. But yeah. And that is, hey, that's the whole worksheet. Sweet. We are done. So yeah, again, the best way to remember the triangle angle bisector theorem, if you need to draw this, I absolutely did. I can't remember the last time I used something like this, so having a diagram that's right next to me was very, very helpful. So if you're allowed to use notes for the formative assessment, I would strongly suggest that the notes be filled with diagrams of proportionalities. Otherwise, yeah, that is how we're going to do things. We're going to keep moving along, and yeah, one more before the assessment.